4, graphing sine and cosine functions. So first we're going to look at graphing y equals cosine x. And I've just picked some values here. I have x equals 0, pi over 2. Remember that's 90 degrees, pi, which is 180 degrees, 3 pi over 2, or 270 degrees, and 2 pi, which is 360. So think about how that's all the way around like one full revolution on our unit circle. So y equals cosine x. So in order to figure out my y values, I'm going to have to take the cosine at all of those different angles. So I'm going to go ahead and extend this page, and at the bottom, first I have y equals the cosine of 0. And I find when we first start plugging these in, it's kind of tricky for students. So I want to think about what the cosine is at 0. Well, at 0 on my unit circle, I know that I have this ordered pair that's 1, 0. And so remember cosine at my unit circle, if my r equals 1, I do cosine is x over r, which is 1 over 1. And so my cosine is 1. So I think what's weird here is that this x and this y is different than the x and y I started with, right? This is the x and y like on the unit circle to find the cosine. Y is going to be whatever the cosine of 0 is. So I'm looking for this y, which is really x over r, and 1 over 1 would just be 1. So my y is going to equal 1. I'm going to go up to my table and put that one down. And then I want to do the cosine of pi over 2. Let's just work across. So pi over 2, we said, was like 90 degrees. So unit circle, now I'm looking here. So that ordered pair would be 0, 1. And of course, my r equals 1. So cosine is x over r, or on the unit circle, just the x value. So the cosine is going to be 0 on my circle. And so y equals 0. So I'm going to go ahead, pop this back up, 0. And now we're going to look at pi. So y equals cosine of pi. So again, unit circle, pi would be 180 degrees. I guess I should be labeling these angles here. So at pi, my ordered pair would be -1, 0. And so my cosine would be my x value here at that ordered pair. So my y is going to equal -1. So again, this is really weird because cosine of pi is going to be that x over r, which equals -1 over 1, or just -1. And so y equals -1. So it's really kind of tricky to look at this diagram and have these x, y things. But again, this y is different. So my cosine of pi is -1. Now I want to look at 3 pi over 2, which is 270 degrees. Let's see. So 270 would be down here. So 3 pi over 2. And this ordered pair would be 0, -1. And so again, my cosine of 3 pi over 2 is going to be my x over r, or 0 over 1. We don't even really need the r on the unit circle. It's just going to be the x value. So that's going to equal 0. And so I'm going to write that y equals 0. So let's go up and put the 0 in. And the last one is 2 pi. But 2 pi is just the same as 0, isn't it? So this is also the same thing as this picture right here. Because when I go all the way around and stop there, I'm at the same place that I was for 0. So this is going to be back to 1. So now I'm going to go ahead and plot this. So at 0, my y is 1. So I'm up here. And then at pi over 2, my y value is 0. So I'm in the middle. And then at pi, I'm at -1. And then at 3 pi over 2, I'm back up in the middle. 2 pi, I'm up at 1. So it goes up, middle, down, middle, up. And because of the way I keep going around that unit circle, and we kind of saw how 0 and 2 pi were the same, if I looked at my next value, if I looked at like 5 pi over 2, it would be the same thing as pi over 2, because they would be coterminal. So I'm going to fill in some more points. I'm just going to keep that pattern going. So I like to talk about how this pattern is up, middle, down, middle, up, middle, down, middle, up. That's the pattern. I don't know why I wrote an A there instead of a U. This is the pattern that we're using for cosine. And the period is going to be this right here. This is the period. That's how far we can go before we start repeating ourselves. So when I get back up to the 2 pi, I start repeating again. So period is going to be 2 pi. Amplitude is going to be from that midline, how far up or how far down. So that's going to be my amplitude. So my amplitude is 1. And that's really the important information that we need here. They talk about frequency also in your book. Your frequency is 1 over the 2 pi. And we don't really care as much about frequency. So next we're going to look at the sine of x. So we're going to graph cosine, we're going to graph sine, and then just like in other chapters in math when we learned graphing, we're going to look at all the different ways that we can transform those graphs. So we'll look at shifting them up and down, shrinking and stretching them. We'll look at all that good stuff. So for sine, I've got to go through pretty much and do all the same pictures. So if I want the sine of 0, let's see, that's going to be an ordered pair right here. And this ordered pair is 1, 0. But on the unit circle, this is almost a little bit easier this time because remember my sine of theta is y over r. So it kind of seems like we're solving for y, but we're using y over r this time. So for whatever reason, sine just seems a lot easier. So because my ordered pair is 1, 0, and 0 is my y value over 1. Remember, we don't even really care about the radius on the unit circle. Sine is just the same thing as y. And so we would have y equals 0. And then I want to look at sine of pi over 2. So we really could just have looked at all of those other pictures that we did. So sine of pi over 2. So it's like 90 degrees, and we have 0, 1 now. My y value is 1, and so my sine is 1. So that y equals 1. And then I want to look at sine of pi. So let's see, sine of pi, that's going to be over here. So my x is 0, or my x is, sorry, -1, my y is 0. I'm kind of getting ahead of myself. And so again, on my unit circle, it's just going to be this y value when I look at sine. So 0 over 1 is just 0. So this y is going to equal 0 because my sine is 0. And then I need to do sine of 3 pi over 2. And so y equals, let's go ahead and graph that. It's down here. So 0, -1. And so again, on the unit circle, my sine of 3 pi over 2 is going to be my y over r, which is -1 over 1. So y is just going to equal -1. So now we're going to go ahead and write all this down. Oh, and when we get back to 2 pi, let's remember that this one is the same. Sine of 2 pi. So I have 0, 1, 0, -1. 0, 1, 0, -1, and then it would be back to 0. So we're going to go ahead and graph. So 0, 1, 0, -1, 0. So it's looking like this. So kind of the same shape, right? Just shift it over. And we call this middle, up, middle, down, middle. Because I'm starting in the middle, then I'm going up, middle, down, middle. So that's a way that we could word this pattern. And I'm going to go ahead and repeat it. Because remember, we could keep it going. We could even keep it going on this side, right? So it's very cyclical. So my period is still this 2 pi, because after I do 2 pi, I'm going around the unit circle again, and I'm just repeating everything. And my amplitude is still 1. So they really look a lot alike. Amplitude is 1. All right, so now we want to list some stuff about amplitude. Amplitude is half the distance from the max to the min. So basically from that middle up or from the middle down. The period, we talked about how long the pattern takes to repeat. Takes to repeat. So just so that we have some working vocabulary. Frequency is the reciprocal of the period. So 1 over the period. And phase shift is when we move right or left. And we will tell that because it will be with our x. So it'll be like something like y equals sine of, let's say, x minus h. This would move at h units right. And a vertical shift is going to be moving up or down. And an example of this is if I have y equals sine x plus k, this is going to be k units up. So just like before, when we're doing something with x, it's always like the inverse. So if it says minus, it's really plus. When we're doing something with y, it's outside of those parentheses with the x, and it's the same sign. So this would be k units up. All right. So now we're going to go ahead and graph y equals -2 cosine x. We're going to draw 2 periods. So let's think about what all these parts do. This negative is still going to reflect. So we'll have to remember that. And then the 2 is going to be a vertical stretch by 2. So that's going to affect our amplitude, right? And we always want to think too about what's going on with cosine. Cosine was that up, middle, down, middle, up pattern, the first one that we did. Up, middle, down, middle, up. I'm always making little notes for myself. Since the vertical stretches by 2, that means our amplitude is now 2. And then again, we're reflecting over the x-axis. And period, we should always write down, even though we didn't change it, is going to be 2 pi. So we're going to draw cosine x. We're going to sketch that with, so we're going to sketch the parent function as well. I think it'll just be good practice. So I'm going to do the parent function in blue, and then I'll come back and I will do our graph that we're trying to do, -2 cosine x. I'll do that in a different color. So let's go ahead, and here's 1, here's -1. And we need to label pi over 2, pi, 3 pi over 2, 2 pi. We're trying to do 2 periods, so I don't know, it's going to be close, isn't it? Let's see, so this would be 4 pi over 2, so 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. And you're welcome to do what I did and not reduce. Sometimes it's just going to be easier to keep that pattern going. I could obviously have written 3 pi here and 4 pi over here, but I didn't, and that's fine. And I kind of squeezed it towards the end, and that's okay too. So my first one, my cosine is going to be up, middle, down, middle, up, middle, down, middle, up. So here's my cosine graph. So that one's going to be cosine of X. And I don't know if I should have labeled it right there or not. That label might be in the way. So my second one is going to be stretched and reflected. So instead of being at +1, now it's going to be down here at -2. Reflecting would be at -1, but we're also stretching. And then it'll be in the middle, and then it'll be up here at +2. So because this hump was at -1, I've reflected it and stretched it. So instead of being at +1 would be the reflect, but I'm stretching it by 2. So I'm just really going through and I am reflecting and stretching this entire graph. So the reflecting means now it's down, middle, up, middle, down. And instead of going from -1 to +1, I'm going from -2 to +2. So this one will be -2 cosine X. So there's one example. All right. Now we're going to look at something that is transformed in a different way. So the x is being multiplied by 2, and I mentioned earlier, I reminded you about how anytime we affect the x, we actually do the inverse. So instead of stretching it by 2, because we're multiplying it, we're actually doing the inverse, and this is a horizontal shrink by 1/2. Horizontal shrink by half. So let's go through and write down some things right now. So our period is normally 2 pi, but we're shrinking that in. So the period is now going to be 2 pi times 1/2, or 2 pi divided by 2. So it's just going to equal pi now. So that means our whole graph is going to be compressed, I think is a really good word, horizontally. Our amplitude is still 1. We didn't vertically stretch it by anything. And our pattern for sine is middle, up, middle, down, middle. So I'm drawing a little picture of it. And so the only thing is this is now going to be happening all between 0 and pi. So I want to think about how I'm really splitting this graph into 4 parts. This part, this part, this part, this part. I'm splitting it into fourths. And so from 0 to pi, I'm going to have to split that into fourths in order to graph all these points. So this time I'm going to be labeling pi over 4, 2 pi over 4, 3 pi over 4. So that's how I'm going to label this time. So we're still, that is a really wavy line, but that's okay. So we're still going to label and do our parent function just because it's good practice. Let's see, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. I'm going to get fancy this time and write 3 pi, 7 pi over 2, and 4 pi. So here's my parent function, because we're kind of practicing those as well. 1, -1. So middle, up, middle, down, middle. All right, so here's parent function. And now I want to graph the sine of 2x. This is just the sine of x. So remember we said that we were going to have, if we're squeezing the whole thing in between 0 and pi, we need to have more marks here. So I'm going to also add in pi over 4, 3 pi over 4. We need to have 2 periods labeled. Pi, this would be 4 pi over 4, 5 pi over 4. This one would be 6 pi over 4, 7 pi over 4. And so the whole graph is happening between here and here. So now I'm going to go up at pi over 4, middle, down, middle, up, middle, down, middle. So I'm welcome to keep that going. But this is that pattern that I'm following. Oops, I went a little bit too high on that one. Let's erase that. That's going to be ugly. Should be pretty, right? And this is getting really messed up, so I think I'm just going to quit. But this would be that sine of 2x. So you can really see, we're graphing the parent function with it, so you can see how it's compressed by half. So instead of the whole thing stretching from 0 to pi, I have 2 periods from 0 to pi instead of just 1 period. So we have horizontally shrunk that by half. We're going to do just a couple more. This one we're changing our period, and we're also, this is going to be that vertical shift up. So vertical shift up 2. And we're still multiplying our period. This time it's 1/3 of x. So remember, it does the reciprocal or it does the inverse. So instead of multiplying the x by 1/3, it's really multiplying the period by 3. So this is a vertical stretch, or sorry, not vertical stretch, horizontal stretch by 3. Horizontal stretch by 3. So my period is going to be 3 times 2 pi, which is 6 pi. Amplitude is still 1. And my vertical shift is 2. All right, so let's go ahead and graph. So always doing that parent function first. So pi over 2 pi, and I don't know if I'm actually going to be able to fit 2 periods of this one in because 6 pi is a really big period. We'll have to kind of jam this in. Pi over 2 pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. And then I'm going to do that mark in between for the half, and then this one's going to be 5 pi, and then 6 pi. So I kind of quit labeling as I got out here. Let's see, 7, 8, this would be 9, 10, 11. It's almost easier for me to label one and then whatever the other for whatever reason. So I am going to be vertically shifting this up by 2 at some point. So 2 will be right here. And then we'll need 3 also because it's going to go 1 unit up and 1 unit down from that vertical shift. So here's my vertical shift line. I like to make a dashed line, kind of like your x-axis would be up and down from that. I just think it helps. Okay, and parent function. So parent function for cosine. So cosine is up, middle, down, middle, up. So up, middle, down, middle, up. And then I'm just going to keep drawing it. All right, and then when I do my horizontal stretch cosine here that's up and down from 2, my amplitude is still 1. So I'm going to start, when I start up, I'm going to start up 1 unit from this line. And then my middle now, my whole graph is going to go from 0 to 6 pi. So I'm going to put, let's see, if I'm thinking about that up, middle, down, middle, up, this is going to be at 0, and this one's going to be at 6 pi. So I'm going to mark that one over there. And then halfway between them is the down one. That's going to be at 3 pi. Okay, so at 3 pi, I would be down 1 unit from the line. And then the only ones that are left are the middle ones. So let's see, halfway between 0 and 3 pi, well, that would be this 3 pi over 2. And then halfway between 3 pi and 6 pi would be this 9 pi over 2. So I can kind of see it's halfway on the graph, or I could actually do it with algebra 2, right? But it's super easy to look at that and just see it. So up, middle, down, middle, up. So it ends up really, really kind of horizontally stretching that out. If I'd had bigger paper, it would be easier to see. But you can see it's definitely been stretched horizontally, not stretched vertically, but horizontally by 3. All right, last graph. We got a lot going on here. So we are going to do a vertical stretch by 2. And we're going to do a horizontal shrink by 1/2. And now we're going to do a phase shift of -π/4. And I am looking at the clock. I'm going to have to start this and do a second video because I need to go ahead and start my Zoom class right now. So I'll stop this for now. We'll come back and we'll do a second video.